My name is Winston Xu. I'm the principal of Integrated Design Associates. We are based in Hong Kong. This is a project that we were commissioned in 2014. As you can see on the slide, the authority say this is the world's friendliest airport for many reasons. Not only is it user-friendly, environmentally friendly, community-friendly, but more importantly, it is a gateway to an area where the people of the Philippines are known to be the friendliest in the world. So there are many, many issues, and also there are many, many challenges relating to this project. First and foremost, this is one of the first privatized airports in the Philippines. It is also the second largest airport. So there's a lot of economic growth over the years, and very soon the existing airport, Terminal 1, has outgrown its capacity. So the authority has provided this concession to a developer to expand the capacity of the airport, and hence Terminal 2 was conceived. This is a 4 million passengers per year to start with on opening day, but ultimately it can be expanded to 9 million within the footprint of the site, which is very constrained on one side by the Air Force base, on the other side by an existing air traffic control tower. Unlike most typical airport where the vehicle road is right up tight to the building, what we have done is to purposely pull the road away from the building, but to create a space around the terminal building so that in the future, the airport authority can create a little bit more community-related facilities, such as retail, restaurants, gardens, not only for the traveling public, but also for staff, community living in the area of the airport, and also for the Air Force base next door. As I was saying, that the building can expand, but that expansion is done in a very modular way. Every module of the arches and the roof is a 30-meter bay. So the building can increase its capacity bay by bay and module by module in terms of lengths. So ultimately, taking it to 9 million, the building would have a lot more aircraft parking bays as well as departure lounges. The planning of the terminal observed the best practice in terms of logical flow. As passengers come into the building, the flow is linear on the same level, and if there is any level change, it's always at the end of the movement, where the movement is always downward and without carrying any heavy baggages. When you arrive, you come in at a mezzanine level, and you go through immigration, and after that, you again descend by escalator or lift into the baggage reclaim hall, through customs, and then out into the landside transportation hub, which is all the taxis, buses, and car pickups. I will walk you through the building slide by slide so that you can get a sense of that space as we come towards the end of the presentation. The architectural clues come from many, many aspects. First and foremost, we felt the vernacular of the Philippines is something we can all learn as modern architects. We also have to consider this is a very large infrastructure development. The resources and the skill sets that you have available in Cebu must be available to work on a project of this scale, something that they can be proud of to be associated with. Not only that, the light industry and also the well-being that everyone coming from the world to Cebu are looking for. What is the feeling and the spatial experience you get in a terminal building? From a vernacular point of view, as we all know, they all are very lightweight, built very simply. All the material are sourced from locally, but more importantly, they are in tune with the environment, be it heat, air, and light. So when we are looking at the terminal building in its modern technology way, the building followed the same principle. The high-pitched roof create a volume in which thermal stratifications can take place, so the air conditioning can be very cost-effective. We make use of the long axis, which is north-south, to open up the gable end to let fuel and light in, and keeping the eaves along the east and west elevation to a very low 3 meter, so that very hot sun doesn't penetrate into the building deep into the space. So our idea is to create a terminal building which is more like a tropical pavilion than a conventional institutional generic airport building. So the idea of create a very lightweight frame that encloses a space that is very airy, full of natural light, but more importantly, it connects with the culture and the locality of Cebu. We feel that this building should have the touch and feel more like a resort than a typical airport. So we wanted the color, the palette, the material to have that sort of warmth, which is unlike most airports. So you can see this building have very little decoration. It speaks in honesty. What you see as a building frame, the architecture, is the interior. We wanted the simplicity run all the way through to the way the building is built. We have to remember that the local skill sets come from boat building. Carpenters are widely available, and yet they are not really going into high technology in building industry skills. So therefore, we want to keep the detailing of the building to be very, very basic, but it has its poetics. That simplicity, going all the way through to the architectural frame, expressed, articulated with clarity. We wanted the timber to be outside so that when you are coming into the building, you can see the frame. From the concrete frame to the arches, 30-meter span, the concrete is articulated in the same way to read the structure from ground all the way to the apex. So these materials are chosen for their strength characteristic and also for their inability of self-finish. There is no material that you need to add on top. What you see is what you get. And so this building has its own aesthetic, and it creates a spatial experience which is very different. It has a warmth very different from many other airports. This project has its challenges, as I say in the beginning. Cebu is located in the central part of Philippines. It's prone to earthquake, 22 typhoons in a year, and very, very heavy rain. So the climate has to be our very first consideration in how we design the building. It's understandable that the developer, for them being the first airport project in the Philippines, they want to be safe. They wanted the building to be built in steel, just like many buildings of its type, of that kind of technical challenge. But we feel, given the weather and the conditions, changeable conditions that you may face during the construction, that there must be an alternative way, a lighter way, a better way, a faster way that may give you benefits in terms of cost as well as time gain. So we always persuade the client to look at timber. But that process is a very long, hard process because we ended up having to develop two designs at the same time, a steel structure as well as a timber structure. But to keep our challenges to a manageable way, we make the building entirely modular so that every component, whether it is built in steel or whether it is built in timber, they are repetitive, exactly the same, and they are expandable and you can addition so that you can reduce the amount of excesses and waste. So at the end, logic prevails. The client went to tender in parallel, one steel, one timber. The steel structure came back cheaper than the timber. However, if you consider what you have to do to a steel structure afterwards, such as adding cladding, then the costs are more or less the same. But the beauty of this is that you can build it so fast. When the client saw the mock-up on site, 1-to-1 scale, he was so overwhelmed by the beauty of that arch built in timber, but also how easy it is to erect with just only a few people on site. So they sold itself as an idea. And of course, our sustainability strategy is to make sure that the timber we use come from a certified sustainable source. And also the energy system that we put into the building are clean. and they are affordable. And that the process that we adopt in the manufacturing of the timber minimize the amount of waste. But the most important thing that we feel very proud is to associate with small-scale manufacturing in the Philippines, down to the choice of and the employment of local resources so that we can ensure the sustainable product and services can be advanced. As an airport, it's a major infrastructure investment. Of course, a lot of technology comes from globally. And from global sourcing, you will get whatever the product you get from an engineering point of view. But what we want to do for this project is to introduce elements within the building that do reflect the local technology as well as cultural elements, such as weaving. So I'm going to walk you through the building now, as though you are passengers arriving at the airport on departure. The taxi, the car will drop you off at the forecourt, and then you walk across our walkway, and then you arrive at the foyer of the departure hall at the upper level. Here, all the meeters and greeters and friends and relatives say goodbye to their friends, because in Philippines, only passengers are allowed in the terminal building for security reasons. When you are in the check-in hall, the check-in island sits along the arches, the foot of the arches, and the building form is very clear in the way it orientates and wayfind and directional. So you follow the procession up to the check-in counters. These check-in counters are actually built by deck chair manufacturers. They have never built any airport furniture before. So we work with them, we taught them how to get the ergonomics right, and also using their technique in weaving. All these furniture are made out of rattan. So then you follow the same direction. You arrive at the immigration control area. After security, you arrive at the duty-free shop, and the duty-free shop has a lower cabin because of fire compartmentation requirements. The roof in the South Concourse has to step down because of the sight line from the air traffic control tower, because they have a requirement that they need to see right to the end of the runway unobstructed. And that creates an opportunity to create a very different kind of space that is very different in scale to the gate lounges that normally are on the flank of the building, where the south-facing wall give you the view and the light. When you depart, you go down the escalator, you walk through the airport boarding bridges, and then when you arrive at Cebu, you can see from the airplane what the building is going to be and from the outside, and you can see right through the terminal building as though it is a very small building. The arrival corridor always have external awareness, and then when you arrive pre-immigration, you go through immigration down to the baggage reclaim hall, and then exit to the car pickup and taxi area. This project has given us a lot of joy, and also working with the local people are very, very invigorating. And in fact, before the building even opens, the social media are already talking about how fantastic a building they're going to have that will give Cebu a lift out of the excitement that they're going to have. Thank you.
There seem to be very few actual gates for the amount of volts you have. I counted 5 gates.
Yes, about 5 contact gates and some remote gates.
When you talked about that this project has the opportunity to expand, did you study that on all the levels? Because I would particularly be interested also in how then all the groundwork or the ground floor work would operate. You know, like how, where do then the airplanes land? how do you deal with all the service equipment? I mean, it really is all about often an enormous amount of logistics on the ground floor you have.
Yes.
So did you study that?
Yeah. The planning of the building is very much based on the module of the arches. So at the departure level, the check-in islands follow the foot of the arch. So every time you expand 30 meters, you get another check-in island. The conveyors that go and take your baggage to the baggage hall at the bottom follows a parallel line running towards the side. So when you extend the building, the conveyor extends in length. Oh. And then when you get to the bottom, every bay you add more carousels for the arrival baggage sorting. When you arrive, you have baggage carousel to claim. Again, those carousels are on a modular dimensions, and they follow. Every time you add a bay, you add an extra carousel. So check-in island, carousels, baggage sorting, they are all on the same 30-meter module.
Okay. Yeah.
So two things that I noticed. One is that the arches are very dramatic, and you integrated some of the structure into it. If you go, for instance, to Schiphol Airport here, when they redid all of the check-in counters and the security, they worked very hard to come up with an interior design version so you don't need stanchions and you don't need all those things. But here I saw they were already putting stanchions and ropes and things like that around. But on a bigger scale, I was also wondering, it seems like you made these big arches. The arches exist independently from the furniture, from the stores, from the air conditioning units that stand there, and in fact from the whole base. The whole base is a big concrete layer, right?
Yes.
And the whole arrival experience is into this sort of relatively low ceiling concrete hall. Was there any thought about trying to make all of that more integrated?
Yes, in fact, actually, one of the very beginning diagram is to explore the arrival experience, to share the same experience as departure, so that you all experience the beautiful arches. However, because of the security requirements that departures and arrival has to be totally segregated, I mean, this is a lot of airports have that requirements. Yeah. And that means that we may either have to lift the arrival to be above the departure, but that means passenger has to climb escalator twice in order to hop over the departing. So there are a lot of pros and cons, and at the end, due to economy, we decided that keep it to a certain level, because departure is about getting from ground traffic to aircraft belly, whereas arrival is to get from aircraft belly to the ground. So therefore, you naturally arriving wants to go downwards, whereas departure wants to go on the same level. And we ended up keeping the flow logic to arrival being below the departure.
I have a question about typhoons, because they're very frequent in that area. And the airport closes down whenever there's a typhoon, so hundreds, if not thousands of people might end up in this building waiting. What provisions have been made for the experience of the passenger who has to endure a 24-hour wait for a typhoon to pass?
Every airport is planned on population figure. So we don't design to a peak number, because that means 90% of the time your airport is oversized. So we design to 30th busiest hour, which means you are about 80% at peak flow. That means there is we also design to a service standard, which is, we call it, in the old days, we call it level C, which means there are certain square meter per passenger. This space is actually a little bit more generous than service level C, so that if there is a typhoon or inclement weather, that passenger has to be held in the building, there are a bit more space than typically.
But are there activities? Is there program space? Is there space designed for people who are just waiting for long periods of time? Or are they just waiting in a same space?
If you have checked in and you couldn't go over to the airside, then you stay in the check-in hall.
Okay.
But after you clear security, you don't normally go back to landslide.
Yes.
So both side of the building has to cope with delays.
Right.
Yeah.
See. Okay. Good. Anything else?
Thank you.